In this video, I'm going to talk about configuring VLANs and shrinking on Cisco switches. So let me first describe the diagram. I have two switches connected through gigabit port, gigabit interface 0/1. And then the first switch 1 is connected to 4 computers. Switch 2 connects to 2 servers. So these servers are going to play the role of web servers. So as you notice here, I will configure 2 VLANs on the first switch, VLAN 100 and VLAN 200. The following ports are member of VLAN 100, port faucet Ethernet 0/1 until up to port faucet Ethernet 0/9. These ports will be members of VLAN 100. Port starting from faucet Ethernet 0/1/10, to port faucet Ethernet 0/19. These ports will be members of VLAN number 200. So we'll have 2 VLANs populated with ports. Now on the second switch, I will configure also 2 VLANs, same ID, VLAN 100, VLAN 200. First VLAN, VLAN 100 will have the following port members, starting from port faucet Ethernet 0/1 up to faucet Ethernet 0/4. The second VLAN 200 will have ports faucet Ethernet 0/5 up to faucet Ethernet 0/9. And the first server, web server here, is going to connect to port faucet Ethernet 0/1, which means it will become a member of VLAN 100. The second server is connected to switch 2 through port faucet Ethernet 0/5. That means also that the second web server will become a member of VLAN 200. So this first web server is part of VLAN 100. The second web server is a member of VLAN 200. Here concerning this host, I have 4 computers here. The 2 computers, host 1, host 2, will be members of VLAN 100. You see, faucet Ethernet 0/1 and faucet Ethernet 0/2 ports are member of VLAN 100, and host 3, host 4 connected through faucet Ethernet 0/10 and faucet Ethernet 0/11. These 2 hosts will become member of VLAN 200. Now, before I start doing this, we have to explain one thing. On Cisco switches, if I go to a Cisco switch like this, the switch is not configured yet. It's not configured. So this is the prompt, and switch does not have any configuration. I go to the privilege exec mode, and from here I will type the command show VLAN brief. Show VLAN brief. So the switch will show me, I will display the VLANs that exist, the default VLANs which exist on the switch. So how many default VLAN we have on switch? We have VLAN 1, this is the default VLAN. All the ports of the switch are member of that VLAN, of this VLAN 1, all the ports, and this VLAN is active. So starting from port 1, faucet Ethernet 0/1, up to gigabit port 0/2, so all the ports that we have, the 24 ports plus the 2 gigabit ports, are members of VLAN 1 by default. Now we have also the legacy VLAN like 1002, 1003, 1004, 1005. These are not used anymore, but they are still there. So by default, Cisco switch has 5 VLANs, which are there from the factory. These VLANs cannot be deleted, they cannot be changed. So you can do nothing to remove them or to change them. So they will stay as they are. And by default, all ports belong to VLAN 1. So we have 5 ports, 1, 2, 3, 4, and we have 5 VLANs, 1, 2, 3, 4, and 5. This is true for all the switches, Cisco switch. Now, since situation is like this and all ports belong initially to VLAN 1, which means that these computers connects all to are all members of VLAN 1. These 2 servers are members of VLAN 1 also on the second switch, and this port gigabit 0/1 is a member of VLAN 1, as well as gigabit 0/1 on the second switch, which is a member of VLAN 1. That means that everybody here is sharing the same VLAN. So if I go to host 1, and from host 1 I will ping the IP address of host 2, host 3, host 4, server 1, web server 1, and web server 2. Look what happens. So I'm going to ping the IP address of host 2. It is replying. Now I will ping here the IP address of host 3. It's replying as well. Host 4, I'll ping the IP address of the web server 1, 100, and web server 2, 150. So they are all replying due to the fact that they all belong to the same VLAN, and there is connectivity between the two switches, which means that this port here connects to this port, which is extending the switching platform. Now what I do, the first thing I'm going to, let me just remove this show port labels when mouse over in logical workspace. Okay, I do that. Now I will go to the first switch and I will start configuring VLANs, the ports to be member of specific VLANs. But the first thing I will do here, I go to the global configuration mode and I will assign the name, host name to the switch, which is SW1. So this is very important. And then what I do, I can do this interface fast Ethernet 0/1, and I will just describe the range of interfaces from fast Ethernet 0/1 up to fast Ethernet 0/9. Okay, so all this range of interfaces, they will all be configured to be on the same VLAN. But before I do that, I have to configure these ports as access ports, which means that the ports are going to be connected to end devices like computers, printers, etc. So first, let me configure these ports as access ports, and then you see when I type switch port, and then what I do, access switch port, access VLAN, and then here I have to specify the VLAN ID, which is 100. What does this mean here? I assign ports starting from fast Ethernet 0/1 up to fast Ethernet 0/9. All these ports now are members of the VLAN 100. So I can do the same thing with the second range, which is from the VLAN 200. The second range starts from fast Ethernet 0/10 up to fast Ethernet 0/19. So all these ports now, I will configure them to become members of the VLAN 200. Now the same story here, what you see, it displays this message, access VLAN does not exist, it's going to be created, it is creating VLAN 200. Now, this is the first way of creating VLANs. So I just create VLANs while I am configuring ports to become a member of specific VLAN. If that VLAN does not exist, it will be created automatically. Now I want to check if these VLANs do, how these VLANs now do exist. I'll go to show VLAN brief. I type show VLAN brief command. Now I see that two VLANs have been added. I have VLAN 100 and VLAN 200. So this name is default name, and it shows that these two VLANs are active. These are the ports which are members of this VLAN, VLAN 100, from port 1, fast Ethernet 0/1 up to fast Ethernet 0/9. The second range of ports starting from fast Ethernet 0/10 up to fast Ethernet 0/19, these ports are now members of VLAN 200, and both VLANs are active. What about VLAN 1? All remaining ports are still member of VLAN 1. So those ports which are not member of VLAN 100 or VLAN 200 simply stay in VLAN 1. So ports starting from 20, fast Ethernet 0/20, and up to until gigabit 0/2, which means now that this port here, which connects to the other switch, is on a different VLAN. I will do a similar thing with the second switch. So I will go to the second switch like this, and this time what I will do, the first thing, I will go to the privilege exec mode, global configuration mode, and I have to assign the host name because it might make things easy for me in the future. I recognize exactly which switch I'm configuring. So when I see SW2, I know that I am configuring the specific switch. Whereas if you don't assign host names to switch and routers or device in general, so it might become a big mess at the end. So now I have the second switch, and the first thing I will do, I will create VLANs. I will create the first VLAN, VLAN 100. You see, once I create this VLAN, I can give it a name. For example, engineering. I will call this VLAN engineering. Okay, and then I will create a second VLAN 200, and I give this VLAN name science. All right, so now if I go back to and display show VLAN brief using this command, what do we notice here? We notice that we have two VLANs which are active. However, these two VLANs, after they have been created, but still that they don't have any members. All ports are still members of the original VLAN, which is VLAN 1. Okay, so what is left now is that I have to populate my VLAN 100 and VLAN 200 exactly as I have done previously. I go to the global configuration mode, interface, range, starting from fast Ethernet 0/1 until fast Ethernet 0/4. So now I'm following this requirement here. Now I'm going to configure this port to be in access mode, and then switch port access VLAN 100. So now I'm saying that the port starting from fast Ethernet 0/1 up to fast Ethernet 0/4, they will become members of VLAN 100. Now look what happens when I click enter. It does not display a message as in previous switch which says that this VLAN does not exist, access VLAN does not exist, creating VLAN 200. Now it will not display this message simply because the VLAN already exists. It has already been created. So I will do this. Now I will move to the second range of ports starting from fast Ethernet 5 to 9. So here I start with 5 and then I go to 9, I guess, yes, from 5 to 9. Now I will configure the switch to be in access mode, which means that the ports will connect to an end device. Okay, and then I will configure this ports to become member of VLAN 200. The same story. The VLAN already exists, so there is no issue here. Okay, so now I'm going to display my VLANs, and I see that two VLANs that I just created have been populated with ports as required through the exercise, by the exercise. Remaining ports belong to or stay in VLAN 1. Now let me just do a simple exercise. I go to host 1. From host 1 I will ping host 2. Okay, now observe that from host 1 I'm going to ping host 2. What happens? There is a reply. Okay, it works fine. Now from host 1 I will ping host 3, which is here. Okay, look what happens. It does not reply. It times out. It times out, which means that host 1 is sending a request, but it does not receive a reply, which means that most likely this request didn't make it to the destination. Why? Because host 1 is in VLAN 100, host 3 is in VLAN 200, and these VLAN are totally isolating these hosts. So when computer 1 and 2 belong to VLAN 100, now they are logically, although they are connected to the same physical switch, but logically they are isolated from host 3 and 4, which are connected or members of VLAN 200. So now VLANs is just a way to isolate logically devices connected to them, to the switch. So now what I do, I'm simply just created two different networks. So the first network is made of ports which belong to VLAN 100. The second network is made by hosts which connects to those ports that belong to VLAN 200. So here I'm now dealing with two different networks. So the next stage now, the next step, what I should do is that I can either keep the IP address like this, or if I think that in the future I will allow connectivity between the different VLANs, I have simply to change the address of the networks. So I go to host 3, and then host 3 I will change this from 16, let's say, to 31. This reflects the fact that host 3 and host 4 now belong to different networks. In TCP/IP, when you say different networks also, it means that networks have different network addresses. So now I'm going to say this. IP address of the web server is, second web server is 172.31.0.150. As I said, you can either keep the same IP addressing as before, but if you intend to establish connectivity between VLAN 100 and VLAN 200 in the future, So it's better you change the network address of the IP addresses assigned to hosts in different VLANs. So like this, hosts VLAN 100 actually is implementing network 172.16.0.0/24, and this is VLAN 100. VLAN 200 is implementing network 172.31.0.0/24. So now we end up having two different networks. So this is network implemented through VLAN 100, and this network is implemented through VLAN 200. So we add this information here. Okay, so now the same thing. Now, from host 1, I cannot communicate with host 3, cannot communicate with host 4, likewise host 2. So the situation is that these two different computers belong to VLAN 100, which is totally isolated now from DOS computer connected to VLAN 200. What about now if I try to communicate with servers which are connected to this remote switch or the different switch 2? Now from host 1, let's do this. I'm in host 1 and I try to ping to the first web server 172.16.0.100. Observe what happens. So also it doesn't work. It doesn't work. So also, of course, definitely if I want to ping 31 now 150, it will not work, not only because of that, but since it has also different network address. Why? Because the link connecting between the two switches is still in VLAN 1. Okay, this link is still in VLAN 1. You see here, gigabit 01 is this port is still connected to VLAN 1, which is totally different from the other VLANs. So one solution, it consists either to connect, let me just do something like this. One solution consists of connecting ports in VLAN 1, let's say Ethernet 03 to Ethernet 02. I know that these ports belong to VLAN 100. So from host 1 now, if I ping the first web server, it's going to respond because I'm simply extending my VLAN 100 through the switches, and I'm connecting the two switches using ports which belong to VLAN 100. So the port here is the port. I use the ports that belong to VLAN 100 in both switches. However, what about hosts 3 and 4? From this host, if I want them to connect to communicate with the second web server, look what happens. There is no connectivity. So what I can do, I can delete this trunk here, and I can provide another link between, let's say, that connects VLAN 200, let's say port 12 to port 6, okay? And this link here is connecting VLAN 200, the two switches, between the two switches. So if I go to host 3 and I ping again the second web server, let's see what happens. Same story. Same story. Okay, so here it is not working. Here what I have done, I connect to VLAN 5 and to port 5, sorry. Port 5. Port 5, port 6 are member of VLAN 200. Now what I'm doing, I'm simply connecting a link between the two switches. Those ports using this link is using those ports in VLAN 200. So let me just view the ports themselves. So this is port 12 and this is port 6. So now from this computer host 3, normally I should be able to ping 172.31. Let me just check the IP. 172.31, yes. Here I have to change the IP address. Okay, I have to go to host 3, also change the IP address from 172.16 to 172.31. Same story with host 4 from 172.31 Okay, now I go to host 3 and I try to ping and I see what happens. Okay, now it's replying. But of course we cannot do this. Assume we have 10 VLANs which are configured on the 2 switches. So we cannot use 10 links to connect the 2 switches together. So each link belongs to a VLAN. So this is out of question. It's not scalable, especially that it will consume a lot of ports. So I can do something like this. Okay, so I will keep this. I connect ports in VLAN 100 and I have ports VLAN 200 connected, right? So something like this. So you see, I will ping from host 1 to the first web server, it works. And then from host 2, I will ping to the second web server and it works as well. However, if we have 10 VLANs, so we have to use 10 links here. So each link is going to consume a port on the switch. So 10 ports will be consumed only for connecting between different switches. And if the topology is more complex, so more ports are going to be connected or wasted because of connecting VLANs directly. So instead of doing this, we're going to configure or connect the 2 switches using one link only. And this link, I will use gigabit Ethernet 0/1, gigabit Ethernet 0/1 on the second switch. So I'm just using the labels here to specify the port through which the 2 switches are connected now. And I will configure this link here as a trunk protocol, as a trunk link. As a trunking protocol, I will choose IEEE 802.1q. So what happens here, this trunk link will allow traffic from different VLANs on switch 1 to communicate with hosts on same VLAN but on the other switch. This is the point. So let me just go to option preference and disable show port labels when mouse over in logical workspace. Now what happens, those hosts in VLAN 100 will be able to communicate with those hosts in VLAN 100 but connected to different switch. Hosts in VLAN 200 will be able to communicate with hosts in VLAN 200 connected to different switches. So it's like we are expanding our VLANs across multiple switches. So we are extending our switching platforms. And the only way to do that is, the only way which is feasible and scalable as well, is to connect different switches using a trunk link. How to do that? I go to the first switch, okay, and in the first switch, I'm going to go to global configuration, and then I go to gigabit port 0/1. And here, I will do the following. Switch ports, I will configure a trunk. So I will configure the switch port as a trunk port. So what I do here, mode, let's say trunk, okay? So now the switch port, the port gigabit 01 is forced to trunk with the other ports. Now I will do the same thing. I will go to the interface gigabit 0/1, switch port mode trunk. All right. And here we are. So let's check if the trunking is successful. So let's do this interface, interface trunk. So we see that the 2 switches, the switch SW2 is trunking. The trunking mode is on. It means that we force the port to go to trunking mode. The encapsulation or the protocol used for trunking is 802.1q. The status is in trunking. The native VLAN is 1. Okay, and all VLANs are allowed to go through that port. Same story with the second switch. Show interface trunk. Right, we notice here that the mode is on. Encapsulation protocol is 802.1q. The trunking status is okay, and native VLAN is 100. Now, I go to host 1. From host 1, I should be able to ping the web server on the second switch. Does it work? Yes. So the traffic will go through this trunk link here. All right. And then I go to host 3, and from host 3 I should be able to ping the second web server and it works. So I can try this with host 2 as well. So from host 2 I'm going to ping the first web server which belongs to VLAN 100, it works. And host 4 I'm going to ping to the second web server which belongs to VLAN 200, sorry, and it works as well. So now each VLAN connected to one switch or let's say hosts in a VLAN connected to one switch will be able to communicate with hosts on same VLAN but on different switch through the trunk link. So the trunk link here is like a bridge between two switches. So all traffic between VLANs is going to cross this trunk link. Of course, you can do some control. You can specify which VLANs are allowed to go through it, which VLAN will be denied, etc. So there are plenty of control that you can do on that, but it's very important to understand the concept of trunking. So what is the use of trunking here? What is the benefit of trunking is that instead of wasting ports, connect different VLANs across multiple switches, we just use one trunk link. Here we are consuming 2 ports only. So we can use the uplink port to connect between different switches. Uplink ports are generally high bandwidth ports because most of the traffic will go through the trunk link. So we need higher pipes in terms of bandwidth to connect different switches. So now if I go to simulate, okay, in packet tracer, I go to host 1, and then from host 1 I will ping the server. So what I notice here, I'm going to bring the packets here from here to the server. And now notice what happens. There is an ICMP packet which go through the trunk link to the server, and then you will have the reply. So you will have the reply. Also the same thing from host 4 to the second web server. Look what happens. There is an ICMP packet you see in pink color. It will go to the second web server and back. Okay. So the trunk link will be used to forward all the frames between all the frames between different switches. So it's very important that you configure these ports as a trunk ports. Like this, they will be able to communicate. The switch will be able to allow VLANs, same VLANs, to communicate. So I hope this video was useful. Thank you for watching.